Given angle theta is in standard position, terminal arm in quadrant 4, and cos theta equals 2/5. We've had questions that start this way before. Even before I get to what the question is, what kind of question does this remind you of? A triangle question. So chances are a really good strategy for figuring this out is going to be to draw a triangle in quadrant 4 with your reference angle. And since we know cos is 2/5, we know this side is 2, this side is 5. How good are you with your a squared plus b squared equals c squared? Pretty good? Square root of decent? 21. Good. So there's our triangle. Now we're asked to find sine 2 theta. Do we have the reference angle for 2 theta? No. We have the reference angle for theta. But we have formulas. What can I change sine 2 theta to? It's equal to 2 sine theta cos theta. Do you know what sine theta is? What is it? Close. Root 21/5. Closer. Negative. Thank you. Right? Quadrant 4. If you make your face scrumpled up just right, someone will see that negative. And cos of theta, well, that was given to us already. We know that it's 2/5. Multiply the tops, multiply the bottoms. This fraction is equal to -4 root 21/25. Nice. Part B says find cos of 2 theta. Now, when choosing which formula to use for cos of 2 theta, it's not going to matter which one you use. If I was doing this one, I would say I like this one the best. Can anyone tell me why? It's simple? They're all simple. The least amount of thetas, but there's the 1 minus 2 sine squared theta that only has 1 theta. It only has one trig function. Why did I discriminate against sine? Well, you could do that with the other ones as well. Okay? Now, I wouldn't have had to do an extra step earlier, right? Because if you look at my triangle, I purposely did the square root of 21 in red to show you had to figure that out, right? Is it possible when you do your math that you might make a mental math error? Yeah? Yeah? Some of you say yeah right away. Says all the time, right? So could you see that sometime you could have been like thinking about something else and maybe you did a squared plus b squared equals c squared wrong and got square root of 21? Maybe you made a mistake there because you had to do a calculation. If I choose this formula, I don't use that square root of 21 at all because I already know what cos is. Cos is equal to 2/5. It was given to me in the question. No calculations necessary. So what's cos squared going to equal? 2/5 squared. If cos is 2/5, then cos squared would be 2/5 squared. And then we still have -1. Let me just finish. I'll get your questions in a second. So now, how do we order of operations? We would square first. So this becomes 4/25 minus 1. I'm going to add these fractions together. I'm going to need a common denominator. Are you okay that I changed my 1 to 25/25 already? Yep. And so this becomes 8/25 minus 25/25. Negative 17/25. Yes? Why can't we plug it into cos 2 theta? Good question. So what would you like to plug into cos 2 theta? 2/5. So if we do that, this would have to be our 2 theta reference angle. But it's our theta reference angle. Okay? We could plug, if that was our 2 theta reference angle, we could do that. But this is just our reference angle for theta because they tell us information about theta, not about 2 theta. So good question. And that's why we can't just plug it in directly. Yes?
Why don't we just change cosine 2 theta into that? Why is it like equals to?
Why did we say, well, this is equal to this, that's the identity. And I just chose one of them. Now, had you chosen the other one, okay? So let's say you chose the cos squared minus sine squared. So instead of choosing 2 cos squared minus 1, you're like, I just pick whichever one's first. That's the first one on my formula sheet, so that's what I'm going with. Because I don't know how to pick the best one all the time. So I get cos squared minus sine squared. Well, what's cos? Cos was 2/5, so cos squared will be 2/5 squared. What's sine? Sine was negative root 21 over 5, so sine squared will be negative root 21 over 5 squared. Can you see that you might forget the negative here in quadrant 4 in doing your work? It doesn't matter, but you still lose a half a mark for making a mistake while doing it. I know. They'll always check for negatives. So that is something on the final exam they'll always check for. So we'll get 4 over 25 minus, this will become positive, 21 over 25. And you still get negative 17 over 25, whether you had that negative there or not. But you could easily make a mistake with that. So that's why I think the first formula is better, less chance of mistakes, because you have only using values you were given. All right. Questions to do for this one? Number 9. So try number 9.